Welcome to this video demo about QDesign, Seleçao's project for the Vectors in Orbit Hackathon. So in QDesign, you can create an account, create workspace, or join existing workspace. When joining a workspace, you find yourself in the data pool. The objective of the data pool is to for the scientists to put all their data, the data they have in the lab, which will be the starting point for the retrieval and coscientist steps. As you can see, everything is updated in real time. We also support visualizing different types of files, PDFs, images, CIF. For the CIF data type, there are multiple ways to visualize it depending on the scientific context. You can also comment on any data entry. It's all updated in real time. You can also manage the objectives, the secondary objectives, the constraints, and the notes for the project, which all will be taken into consideration for the retrieval and coscientist steps. Now let's go ahead and start retrieving. The process takes a long time and returns a full knowledge graph of similar entries or useful entries. It also supports visualizing all these kinds of files. The edges of the graph are actually a feature we implemented by forking Qdarnt and modifying its source code, and now you can know which features influenced it the most in choosing two proteins as similar. You can also add notes to a certain data entry or delete it, mark it as untrusted or high trust. We also have a feature to expand the graph in a certain direction. Like in this example, we expand to the direction of this protein and we get another protein, and as marked by the edge, you can see that the biological features are flexibility and context, which mean these two proteins are most similar on that field. And now we move on to the co-scientist part, which will be presented to you by my friend Ahmed Saad.
Okay, so thank you, Matas. I'm going to present the coscientist part, which is a multi-agent system automated scientific hypothesis generation. It uses 5 different AI agents, all working together on biological knowledge graphs. Okay, so this is the user interface for the AI agents part. There is a sidebar which can help you customize how the AI agents work and what you want to do exactly. You can launch a discovery, which I already did for this video. Okay, so how our AI agent system works. It has five main stages. The first one is the planner, which finds relevant pathways in a knowledge graph. And this is what the knowledge graph planner did. The second one is a semantic ontologist, which adds biological context and definitions, and that is exactly what it did. The third one is the hypothesis generator, which acts like a scientist. It helps generate the initial hypothesis using 7 points framework. Okay, so the fourth one is a second scientist, which acts as a hypothesis expander. It expands with quantitative predictions and experimental protocols. And the fifth and the last one is the critic, which evaluates and gives either one of 3 decisions. It either approves, asks for revision, or rejects the hypothesis. And for this case, it asks for revision because the novelty score is 6 out of 10. You can also view the raw data for all the specific agents, and this is the final result. It completed the 5 stages successfully. You can download the results like this. For this specific use case, we didn't enable the human in the loop preview. You can enable it in the sidebar, and you can customize when the human will interact, either after the planner, after ontologist, etc. Okay, so thank you for your time.